Hello everybody, welcome into another lesson. So today we're going to talk about inequalities for one triangle. So we're only going to deal with one triangle at a time today. The next lesson we'll talk about inequalities for two triangles. But today we're dealing with one. So we have three new theorems we're going to learn today. But good news for everyone. I think everyone's, or most of you are going to be happy with this. We're pretty much done with proofs for the rest of the course. Now, we're going to have a little bit when we get to coordinate geometry much later in the course, but we're just a little under halfway through the course, so we're getting there towards Algebra 2 trig. But anyway, the first theorem we're going to learn today that if one side of a triangle is longer than a second side of a triangle, then the angle opposite the longer side is larger than the angle opposite the smaller side. So here, to illustrate that, you have triangle ABC. Well, side AB has a length of 5, side AC has a length of 6. So it's clear that side AC is greater than side AB. It's longer, right? Therefore, that means that angle B, its opposite the side with has a length of 6, would be greater than angle C, which is opposite the side with length of 5. That's all that's saying. And I got some exercises to illustrate this theorem. We are going to illustrate that. So let's go ahead here. Let's do some exercises. Okay. Here we have triangle TRS. We have triangle TRS. TR has a length of 21. This isn't exactly drawn to scale, forgive me. RS has a length of 22, TS has a length of 23. Okay, so we have a scalene triangle here. The goal is we want to name the shortest side and then the longest side. So, according to what we just learned, what is the shortest side? Well, the shortest side here obviously is 21. Well, we want to name the smallest angle. I'm sorry. That's what I'm trying to say. We have the shortest side. We want to name the smallest angle. So what is the smallest angle of this triangle? Well, the shortest side is 21, right? So that means the angle opposite that angle S would have to be the smallest angle. So angle S is actually the smallest angle. Now, what's the largest angle? The largest angle, well, let's look here. The longest side is TS with a length of 23. So the angle opposite TS is angle R. That means angle R would have to be the largest angle, according to the theorem that we just learned. So that really isn't that bad to understand. Now, what's next here? Let's do another one. What's this triangle going to be called? WVU. WVU. What do we have here for lengths? 10, 14, and 9. Again, I apologize, it's not the most scale drawn, but you'll get the point here. So we're given three sides of the triangle WVU. We need to, once again, we're going to start with finding the smallest angle. So what would the smallest angle of this triangle be? Well, the smallest side obviously has a length of 9. That would be VU, right? So the angle opposite side VU, which would be angle W, would have to be the smallest. So angle W is the smallest angle. Now let's find the largest angle. So to find the largest angle, we need to find the longest side, which would be side WU with a length of 14. The angle opposite side WU is angle V, which would make that the largest angle. So angle V is actually the largest angle of this triangle. Alright. Some of these are going to seem redundant, but I think this is an important exercise to drive home. This is a very important theorem to drive home here. Alright, so we have triangle XZY. See, 21, 23, and then 29 for this length. Okay, so once again, let's find the smallest angle to start with. So you have triangle XZY, side XZ has a length of 21, side ZY has a length of 23, then side XY has a length of 29. In order to find the smallest angle, let's first find the side with the smallest length. That's going to be XZ with a length of 21. The angle opposite that is angle Y, therefore angle Y is the smallest angle. Now let's find the largest angle. So to find the largest angle, you'll find the side with the longest length, which would be XY with a length of 29. The angle opposite XY is angle Z, therefore angle Z is your largest angle. So smallest is angle Y, largest is angle Z. All right. Let's do 3 more like that. Let's do 3 more, but these are a little bit different. If I could draw, that would help, right? Let's see. This side has a length of 12, this side has a length of 12, this side has a length of 13. And then we need to label our angles. This is angle 1, angle 2, angle 3. Okay. So the goal is only this time to find the largest angle. We have an isosceles triangle here with lengths 13, 12, and 12. What would the largest angle be of this triangle? Well, obviously it's going to be the angle opposite the side with the length of 13, which would be angle 2. So angle 2 would actually be the largest angle of this triangle. Alright, what's next? This is a real good one. You're about to see why I'm saying that in just a minute here. Alright. We have x, x plus 1, x minus 1. So we actually have some variables in here. And then let's see what they number the angles. Here is 1, 2, and 3. So the goal is still find the largest angle, although we have variables. But honestly, does it really matter what x is? Does it really matter? You have x, which is the base. Whatever x is here, this side is x minus 1, which is already smaller than this. And then you have the largest side here, which is x plus 1. So it's plain to see that x plus 1 is the longest side. That means angle 1 would have to be your largest angle for this particular triangle. That's what that would have to mean. I got one more exercise for this, then we're going to go on to the next theorem. This may be the best one yet. Oh yeah, this may be the best one yet, I think, in my opinion. Then we have a diagonal running from here to here. Oh, very good. Yes, we have a parallelogram. This length is 22. The diagonal has a length of 21. This side has a length of 20. Okay? Angles 1, 2, and 3. Well, again here, so this is different because we have a parallelogram that's split into two triangles. We need to figure out which of these three angles is the largest. Well, what do we know about parallelograms? That opposite sides are congruent, right? So that means this side here would also have a length of 22. So let's go ahead, let's do that for missing information. Now that we've established this side has a length of 22, let's find the largest angle. So this side here is a length of 20, this side has a length of 21. Obviously the side with the length of 22 is the greatest, right? So that means the angle opposite that 22, which is angle 3, is the largest. So angle 3 is actually the largest angle. So yes, our past theorems and everything are actually coming into play here. Alright, so that's it for that theorem. Let's talk about the next theorem. Okay, so the next theorem states that if one angle of a triangle is larger than a second angle of the triangle, then the side opposite the larger angle is longer than the side opposite the smaller angle. And let me draw another diagram here to illustrate the point I'm trying to drive home with this particular theorem. Draw a triangle A, B, C. So let's see here. We'll say this side has a, let's see, this angle is 70 degrees. This angle is 65 degrees. Okay. So let's talk about this new theorem. It's basically the converse of the last one we just had. It states that if one angle of a triangle is larger than a second angle of the triangle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So here again we have triangle ABC. This time you're given that angle B has a measure of 70 degrees, angle C has a measure of 65 degrees. So it's plain to see that angle B is greater than angle C, therefore that means the side opposite angle B, which is AC, is greater than the side opposite angle C, which is AB. And I have some exercises to illustrate this point too. So let's do that. Okay, so this time we need to find the longest side and the shortest side of the triangle. Now, you're only given two angles, right? What you need to do to really figure this out is you need to find that missing angle, angle B. So what we can do here, of course, is take the measure of angle B plus 70 plus 75 equals 180. Right? We want to figure out that missing angle to truly get an accurate result. Which means the measure of angle B plus 145 equals 180. Which then would have to mean that the measure of angle B equals what? 35. So angle B is actually equal to 35 degrees. So let's fill that in just so we have that for good measure. Okay. Now what we're tasked with is start out finding the shortest side. The shortest side, obviously, is going to be opposite the smallest angle, which is angle B. That's the smallest angle with 35 degrees. So the side opposite that is AC. So the shortest side is going to be AC. So then, of course, we're going to find the longest side. The longest side is going to be the side opposite the largest angle. Well, the largest angle is 75 degrees with angle A. So that means the side opposite that is side CB, or BC, however you want to say it. I'll just call this CB for simplicity's sake. So your shortest side is AC, your longest side is CB. Alright. What's next? Triangle FED. This is triangle FED. They even give us that angle E is a right angle, so we have a right triangle. Angle F is equal to 43 degrees, right? Okay, well, we don't know angle D. Of course, we're tasked with finding the shortest side and the longest side. Oh, this isn't drawn to scale, I apologize, but Well, what do we know here to find angle D? That the acute angles of a right triangle are complementary, right? So all we have to do is take the measure of angle D plus that 43 and set it equal to 90. Of course, you could add all these together, set it equal to 180 and still get angle D, but why put yourself through that? So the measure of angle D would therefore have to be 47. So let's go ahead and fill in angle D for being 47 degrees. Okay, now we want to find the shortest side and the longest side. Start with the shortest. So the shortest side, of course, is opposite the smallest angle. The smallest angle is going to be angle F with a measure of 43 degrees. So the side opposite that is side ED. So therefore ED is the shortest side of this triangle. Now what's the longest side? I think this one's fairly obvious, because angle E has a measure of 90 degrees. That's obviously your biggest angle. And it's always true that in any right triangle, the hypotenuse is the longest side. It always is. So your longest side is FD. So you would have the shortest side being ED, the longest side being FD. One more triangle like that. What do they call this bad boy? IHG, GIH. Okay. Triangle GIH with what? This one's 121 degrees. This one's 32 degrees. Okay, so once again, we're tasked with finding the shortest side and the longest side. Well, in order to get an accurate representation, we need to find angle I. So we can use the fact that the measure of angle I plus 32 plus 121 equals 180. Which would then give you that the measure of angle I plus 153 would equal 180, which means that the measure of angle I equals 27. So we've solved for angle I. That means this angle right here is 27 degrees. So we've actually now found the smallest angle. So the shortest side, of course, is going to be the side opposite the smallest angle, which in this case, the smallest angle is 27 degrees. The side opposite that is GH. So side GH is your shortest side. And then, of course, your longest side will be the side opposite the largest angle, which is 121 degrees. The side opposite that is GI. So GI would hands down be your longest side of the triangle. All right, what else? We have, let's see, I'm going to do 3 more exercises with this theorem, and then we're going to go on to the final theorem. So we have triangle DEFG F, we're going to try to find the longest side of this triangle, just the longest side. Well, angle F has a measure of 60 degrees. Now, this is where it gets interesting. Angle D has a measure of angle of K. Angle E is K plus 2. Okay, so it's going to be hard to determine which side's the longest if we don't know what K is, right? So all we need to do now is take K plus 2 plus 60, set all that equal to 180, and then we'll find the value for K, which would then give us 2K plus 62 equals 180, which would then give us that 2K equals 118, which would mean that K equals 59. Okay, so we can put here now that K equals 59 degrees. K plus 2 equals, then if K is 59, you add 2, that's 61 degrees. So what we really have here now is a triangle with angle measures 60, 59, and 61. To find the longest side, it's obviously the side opposite the largest angle, which would be the side opposite the 61 degree angle of angle E, so side DF would be your longest side. So DF is definitely your longest side of the triangle. Alright, two more with this theorem. Not the best drawing I've ever done, but we'll get it. There we go. RWTS. Alright, what else are we given with this? This is also 60. This is 54. This is 65. Alright, so we obviously want to find the longest side. We have a quadrilateral split into two separate triangles. Well, that's no worry. I think it's obvious here that angle R would also be 60, because if you add 60 plus 60, take that from 180, you'll also get angle R 60. So that side wasn't hard. Now, to make a true determination, we need to find angle T. So, of course, we're going to take 65 plus 45. So the measure of angle T plus 65 plus 54, whoops, I'm writing it backwards, dyslexic moment, plus 54 equals 180, which would then give you that the measure of angle T, so it'd be 69 plus 119 equals 180, which would then give you that the measure of angle T equals 61. So angle T has a value of 61 degrees. Okay, now that we've solved for all these angles, we need to find the longest side, which I think is going to be pretty obvious that the largest angle is 65 degrees, therefore your longest side is WT. So WT would have to be your longest side. All right, one last exercise with this theorem. This is going to be a fun one. Oh, Lord. This is an interesting one because we have here three right triangles. We actually have three right triangles. This angle has an 8-degree measure. This angle is 9 degrees. This angle is 10 degrees. So we have to find the longest side. Well, let's just take each of these triangles separately for a minute, because it's obvious that none of the 8, 9, or 10 degree opposite sides are going to be the largest, right? Those are some pretty small angles. But we know that angle A, since we have a right triangle, is obviously the complement to 8 degrees. The complement to 8, you just subtract 8 from 90, you would get 82. So angle A has a measure of 82. Angle OBC would be 90 minus 9. This would be a measure of angle, this would be 81 degrees. And then the measure of angle OCD, OCD, would be 90 minus 10, which would be 80 degrees. Now we actually have something we can work with. We want to find the longest side, so the largest angle we see, though, this is tricky. This is very tricky. What is the largest side of this particular? Well, I think it's obvious that we have three right angles, right? Your largest angles are actually 90. So in this case, you have three longest sides. That's actually going to be OA, which is equal to OB, which is equal to OC. All three sides actually tie for OA, OB, and OC actually tie for the longest sides because they're all across from right angles, from 90-degree angles. Alright, I got one more theorem for today and a few exercises with that, and then we're done. So, this one is called the Triangle Inequality. So this theorem that we're about to learn is called the Triangle Inequality. This theorem states that the sum of two sides of a triangle is greater than the third side. Well, I should say the sum of the length of two sides of a triangle is greater than the third side, but I think you get the point I'm trying to drive home. So let's draw a triangle here for this. A, B, C. We have triangle ABC. So what this is saying here, this is saying, for example, you take side AB plus AC, so side AB plus AC would be greater than side BC by itself. because the sum of the length of two sides of a triangle is greater than the length of the third side. What else can we say? That the length of AB plus the length of BC, so AB plus BC would be greater than AC. And then of course we could have the length of AC plus BC is greater than AB. It almost sounds like Pythagorean theorem for a minute, but it's not. Because remember, Pythagorean theorem is a squared plus b squared equals c squared. This is simply just saying that just take the lengths without squaring them of two sides. It's always going to be greater than the length of the third side. So let's do a few exercises with this theorem. Alright, so in this particular case, is it possible for a triangle to have the following lengths? Alright, so we're about to be given some lengths here, right? We need to determine if it's possible for triangles to have that. You have lengths 10, 9, and 8. So how are we going to determine if it's possible for a triangle to have the lengths? Well, the Triangle Inequality Theorem. You just take two sides, right? You have 10 plus 9, which we know equals 19. Well, 19 is definitely greater than 8. That checks out, so the answer is yes. A triangle totally can have lengths of 10, 9, and 8. Just take the first two sides, add them together. 10 plus 9 equals 19. It's definitely greater than 8, which would be the third side, so yes, a triangle can have those lengths. Now, what about in the next exercise? We have lengths of 6, 6, and 20. Well, all you got to do is take... Is it possible? It might not look possible if you take the first two sides and add them together, because you get 6 plus 6 is 12, which 12 would be less than 20. But you got to think outside the box a little bit. What if we took 6 plus 20? Sometimes these won't always be in numerical order. If you take 6 plus 20, you would get 26, right? Well, 26 is greater than 6. So actually, yes, it is possible. It's entirely possible to have a triangle with side lengths 6, 6, and 20. You can't always go by what the first two numbers are. You got to think outside the box a little bit, and sometimes you'll have to take the first and third or the second and third and set it, equal to each other and see what you come up with. But yes, it's entirely possible. What's the next one? 7, 7, and 14.1. Okay, so is it possible to have a triangle with length 7, 7, and 14.1? Well, once again, if you took 7 and 7 and add them together, you would get 14, which is just a little less than 14.1. But think outside the box. What if I took 7 plus 14.1? What's that going to give me? 21.1. Well, I think it's obvious that 21.1 is definitely greater than 7, so the answer is yes. It's entirely possible to have a triangle with those lengths. So this is all the Triangle Inequality Theorem is saying. It's actually not that bad once you understand it. Alright, 16, 11, and 5. Is it possible to have a triangle with lengths 16, 11, and 5? So let's add 16 plus 11. I think it's already clear to see yes, but let's do it anyway. 16 plus 11 equals 27. 27 is greater than 5, so definitely yes. You can have a triangle with lengths 16, 11, and 5. Okay, how about 0.6, 0.5, and then 1? Is it possible for a triangle to have a length of 0.6, 0.5, and 1? Well, let's go ahead and add up the first two sides even. 0.6 plus 0.5 equals 1.1. Well, 1.1 is definitely greater than 1, so yes. It is actually possible for a triangle to have lengths of 0.6, 0.5, and 1. And last one for this type. You have 18, 18, and then 0.06. So, is it possible for a triangle to have lengths 18, 18, and 0.06? Yeah, definitely. 18 plus 18 is 36. It's greater than 0.06. But let's say we even took 18 plus 0.06. You would get 18.06, which is greater than 18. So hands down, yes, that's entirely possible to have triangles with those lengths. Absolutely. Alright, I got one last set of exercises that involve this triangle inequality theorem. But these are a little bit different from what we've done so far. So, and these exercises, there are going to be 4 of them. They give you the lengths of 2 sides of the triangle. The third side of the triangle must be greater than, and then less than. So this is a little bit different. So the third side of the triangle must be greater than and less than with, what are your first 2 sides? The first 2 sides are 6 and 9. So they give you 2 of the sides are 6 and 9. So how in the heck are we going to find the range of what the third side must be? Well, first thing you're going to do is take x, let x equal the third side, right? X plus 6, set that greater than 9, which we know to solve that inequality, x would have to be greater than 3. Next thing, take 6 plus 9, that would have to be greater than x. So first you're taking x plus your first side, setting it greater than the second side. Then you take your 2 sides together, set it greater than x, which means then 15 would have to be greater than x. And then last but not least, you're going to have x plus 9 greater than 6, which would then just give you that x is greater than negative 3. Well, right away we notice we have a negative solution. If you have a negative number, you throw that out right away because you can't have a negative length. So of course we have x greater than 3. Whoops, not 5. Why am I writing 5? X greater than 3. Well, if 15 is greater than x, that means x is actually less than 15, right? So those would be your answers. X has to be greater than 3 but less than 15. That would be the range for your third side, what the lengths could be. Greater than 3 but less than 15. And I got 3 more exercises like this. What's the next lengths they give us here? Okay, they decide to give us 15 and 13 this time around. So we got lengths 15 and 13. So first, once again, take x plus your first side, which is 15, set that greater than 13, which would have to mean then that x is greater than negative 2. Right away we disqualify that because we have a negative length. That doesn't work. Next thing is take 15 plus 13, set that greater than x, which would then give you that 28 is greater than x, which has to mean that x is less than 28. And then, of course, finally, you'll take x plus 13, set that greater than 15, which would just mean that x is greater than 2. So your answers for this are that x has to be greater than 2. Your third side has to have a length greater than 2, but less than 28. That's what that means. So again, start out by taking x plus your first number, set it greater than the second number. Next, take your two sides, add them together, set it greater than x. And then you finally take x plus your second number, set it greater than your first number, and you'll get your ranges for greater than and less than. 2 more exercises like this. Good one. You have a length of 100 and 100. So we have a length of 100 and 100. Okay, well, in this case, you're going to take, of course, x plus 100, set that greater than 100. Well, right away then, we would have that x is greater than 0. Which, being greater than 0 could be anything. So that's actually an acceptable answer. We actually just solve for steps 1 and 3, because when we go to do this in the third step again, x plus 100 is still greater than 100. So all that's left now is to take 100 plus 100, set that greater than x, which means that 200 is greater than x, which means that x is less than 200. So the lengths for your third sides must be greater than 0, but less than 200. That's the possibility. For your third side, x has to be greater than 0, but less than 200. And I got one more, and then we're done. Alright, then they throw a variable in the book. Actually, I think we'll do 2 more. There's a reason for that. We have length of 7n and 10n. All of a sudden we got variables, but that's still not too bad. So we're going to do 2 more because they have variables. Alright, so first, again, you'll take your x plus your 7n, you'll set that greater than 10n, which means then that x would have to be greater than 3n. X is greater than 3n. Now take your 7n plus your 10n, set that greater than x, which then means that 17n is greater than x, so x would have to be less than 17n. And then finally, you'll take x plus 10n, set that greater than 7n, which would then give you that x is greater than negative 3n. Well, let's discard that right away. We don't want to have a negative length, so x, the length of the third side would have to be greater than 3n, but less than 17n. Those are the lengths of the third sides that you could have. Greater than 3n, but less than 17n. Alright, for real, one final one. It's a variable one, but slightly harder than the one we just did. This time you have a length of k, and then k plus 5. So you have a length of k and k plus 5. So of course the goal is in this case to have x plus k greater than k plus 5, which would have to mean that x is simply greater than 5. So x has to be greater than 5. Well, then we would take k plus 5, set that greater than x, which would then give you that 2k plus 5 is greater than x, which would mean that x would have to be less than 2k plus 5. And then last but not least, take your x plus k plus 5, set that greater than k, which would simply give you that x is greater than negative 5, which we can throw that one out since we have a negative length. So the answer is that the length of the third side has to be greater than 5, but less than 2k plus 5. That's what you would get. The length of the third side has to be greater than 5, but less than 2k plus 5. So that's it for this lesson. Next lesson, we are going to go on to inequalities for two triangles. So I hope everyone has a good day. Take care.